first topic we're taking up today is electron configurations. Now, this is going to be a culmination of all the things we've done with the location of electrons based upon the four quantum number, M, L, M, and S. All right? And as we talked about before, we don't really need to know specifically those quantum numbers to figure out where the electrons are. We use the quantum numbers as a guide to understand the options we have. But periodic table is what it's all about. All we have to do is look at the location of the elements in the periodic chart. Now the thing you have to remember is that the number of electrons that we have in each of these elements, the highest energy one is what the four quantum numbers describe. But take like element for beryllium here. The beryllium element, one atom of it, has 4 electrons in it. And it contains the highest energy electron of hydrogen, the highest energy electron of helium, the highest energy electron of lithium, as well as the highest energy electron of beryllium, all together. So we use the highest energy electron of each of these elements by proclaiming that these elements are representatives of the electrons associated with it in its highest level. And that gets us to where all the electrons can possibly be found. Now, again, we are never 100% certain that at any particular moment in time that they will be found in exactly those spots, because they are moving at the speed of light. They are affected by the location of the protons in the nucleus, but generally what we are talking about is 100% correct. On an average, I guess, maybe is the best way of looking at it. So, for beryllium, we know that these 2 electrons here are found in the first level, and the only type of path or orbital we have in the first level is the spherical path, so we call these S electrons. So these 2 together is called 1s2. 1s2, which looks like this. We write the coefficient of 1 to show that it's level 1. The S describes the S electrons in the spherical paths, and the fact we have 2 electrons in that path. We don't say 1s squared, we say 1s2. Okay? So they are looking like exponents, but they don't have the meaning of the exponent in mathematics. We are giving it its own value or meaning in chemistry. The next 2 electrons are represented by lithium and beryllium. Now they're in the second row, so they are second level electrons, but they're found in these 2 columns over here. And we've established that any electron found in these 2 columns right here are the S electrons. The only exception is that helium right here, which you would think belong right here, but there's a reason why we put it there, and that comes later on in the course. So we have 2 S1s, so we call that 1s2. We have 2 S2s. So this is 1s2, 2s2. And so the electron configuration for beryllium is 1s2, 2s2. Okay? So we're just going to follow along in the periodic table where all the electrons are. And the thing about it is that the sum of these electrons right here, these exponents, add up to the number of electrons you should have, which makes sense, but it also is going to be the same as the number of protons. And what number represents the number of protons? Atomic number. So the sum of these must add up to the atomic number of the element we're looking at. Beryllium is 4, 2 plus 2 is 4, life is good. All right? Next one says, what is the electron configuration for phosphorus? We're going to continue the pattern that we showed in the previous videos. Put it all together here. So we start over again. 1s2 for the 2 electrons represented by hydrogen and helium. 2s2 for the lithium beryllium. Now all we're doing is we're going along numerically. 1, 2, 3, 4. Next is 5 through 10 right here. Now phosphorus is down here, so that's where we're going to stop. But right now we passed 4, we're going 5 through 10. This is still a second level path. But now the shape of the path has gone from spherical to 2, three-dimensional figure 8. Now remember, there are 3 paths that have the shape of three-dimensional figure 8s for every level. And there's 2 electrons in every path or orbital. So we have a total of 6 possible electrons. Well, when we go from 5 through 10, all 6 are represented. So this is 1s2, 2s2, 2p6. The next one after 10, 11 and 12, sodium and magnesium. Sodium and magnesium are in the 2 columns on the left-hand side, so they represent s electrons. And they're found at the 3rd row, so they are 3rd level s electrons. So the electron configuration up to this point is 1s2, 2s2, 2p6, 3s2. Okay? Now, we have 3 more electrons left accounted for. Unaccounted for here, so we have, these are 3rd level. This is that block of 6, so those are p electrons. But we only have 3 instead of a full 6, so we end this with 3p3. So the electron configuration for this is 1s2, 2s2, 2p6, 3s2, 3p3. And again, you add it up. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 3 is 15. Phosphorus is element number 15. It's that simple. Next one, we're going to look at molybdenum, or molybdenum. All right, so molybdenum is element number 42. This is in the D range. We know it's going to end with a D. All right, so let's go through what we did up to this point. 1s2, 2s2, 2p6, 3s2. That brings us to aluminum. We're going to go past all of these because we're going to end up right here. So 13 through 18, aluminum to argon, 3p6. Potassium and calcium, that's 4s2. Now we get to this area we haven't touched on yet today, but we've touched on this before, and that is the fact that these are d electrons. And d electrons first appear in the 3rd level, but it takes more energy to put electrons in the 3rd level, D, than the 4th level, S. So that's why 4s2 comes first, and that's why it's listed first in the periodic table. And we go through all 10, from scandium through zinc, so that's 3d10. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. That brings us to gallium. Now gallium is a p electron. That means it's going to go back to the 4th level. So the S's and P's are both the same row and level, same number. The D's are 1 row late, and of course the F's are 2 rows late. But we're not going that far on this one. We're just going to go to molybdenum right here in the D's. Anyway, so gallium through krypton, that is in row 4, and they're all 6 P's here, so that's 4p6. Rubidium and strontium are 5s2. And molybdenum is over here. This is in the D's in the 5th row, but they should be in the 4th level. So that's 4d1, 2, 3, 4. So that's what it is going to end with, is 4d4. So when the smoke clears, this is our electron configuration. 1s2, 2s2, 2p6, 3s2, better fix that. 3p6, 4s2, 3d10, 4p6, 5s2, 4d4. We add them up, we get 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, plus 10 is 30, 36, 38, 42. Molybdenum is indeed element number 42. Yay!